In this video, we are going to talk about Node.js event-driven architecture. Imagine you are the conductor of a massive orchestra. Each musician plays their part at just the right moment, creating a harmonious symphony. But what if they all waited for each other to finish before playing? The music would be a mess. Node.js operates like a skilled conductor, using an event-driven architecture to orchestrate a seamless performance where tasks flow smoothly without waiting on one another. So, let's dive into how this magical system works, starting with the star of the show, the event loop. In the world of Node.js, the event loop is the conductor, keeping everything in synchronization. Picture it as a continuous loop that never stops spinning, ready to react to any task that comes its way. Whether it is reading a file, handling a network request, or responding to a user action, the event loop makes sure each task gets the attention it needs without holding up the show. So, how it works? First, incoming requests. Imagine the audience throwing requests at you: play this file, fetch this data, and you are catching them all one by one. Next, task queue. But instead of handling them immediately, you hand each request to different sections of your orchestra. These tasks go into a queue waiting for the right moment. Next, event loop phases. The event loop goes through different phases like checking timers, processing IO callbacks, and handling immediate tasks. Each phase is like a different section of your orchestra getting its turn to play. Let's say you are reading a file. Task begins. Read this file, you say to your IO section. But you don't wait for them to finish. You move on to the next task. Meanwhile, the event loop continues handling other requests like logging a message or responding to a quick HTTP request. Next task completed. When the IO section finishes reading the file, they signal you and you jump into the process the file's content, ready to handle whatever comes next. Node.js doesn't like to keep you waiting. With non-blocking I/O, it performs tasks in the background, allowing you to move forward without delay. Here is an example. So here what happens: you kick off the file reading but don't stick around for it to finish. Instead, you immediately move on to the next task like logging reading file. When the file is ready, the event loop taps you on the shoulder and you finally process the data. So, callbacks are like your trusty sidekicks in this adventure. You hand them the baton, and when the task is done, they jump in to finish the job. But what if you want your code to look cleaner and avoid the infamous callback hell? You can use promises and async await. These are the tools that help you handle asynchronous tasks with elegance. Now your code looks almost as if it is reading the file synchronously, but in reality the event loop is still spinning making sure everything happens efficiently in the background. In this video, we are going to talk about Node.js single-threaded architecture. Imagine walking in a cozy coffee shop. You see a barista working alone behind the counter. This barista, let's call him Node. It like your favorite multitasker, taking orders, brewing coffee, and serving customers, all with a smile. But here is the catch. Node can only handle one task at a time. Node is fast, really fast. He takes an order, let's say making a latte, starts the process, and while the coffee machine is brewing, he quickly takes another order, like a cappuccino. As soon as the latte is ready, Node serves it and then gets back to the cappuccino order. This is the essence of Node.js. Single threaded but non-blocking. It means Node handles one thing at a time, single threaded, but it doesn't get stuck waiting, non-blocking. So, while the coffee machine is doing its thing, Node is free to take care of other tasks. Coffee machine represents file system, database or API here. Now imagine it's rush hour. There are 20 customers waiting for their coffee. Node doesn't panic. Thanks to an event loop, he keeps track of every order and ensures each one gets served. This loop is like an invisible notepad where Node jots down tasks and checks them off as they get completed. This single-threaded nature makes Node.js efficient and great for handling tasks that involve a lot of waiting, like dealing with databases, APIs, or files. It's not about doing everything at once, but managing tasks smartly, ensuring that nothing gets stuck in the process. In this video, we are gonna talk about Node.js non-blocking I/O operations. Imagine you are managing a pizza delivery service. You have got one delivery driver, but he is super efficient. His job is to take orders, deliver pizzas, and handle all customer interactions. But there is a twist. He can handle multiple orders at the same time without making anyone wait too long. How? By using the power of non-blocking I/O. Non-blocking I/O is like your driver who doesn't wait around for pizzas to be ready before taking the next order. Instead, he quickly moves on to the next task and comes back when the pizza is ready. This keeps the service fast and efficient. In Node.js, when you make a request to the file system, database, or another service, the, the program does not stop and wait for the response. Instead, it continues executing other code. When the response is ready, Node.js gets back to it. Let's first see what would happen if your pizza service used blocking I/O. Imagine if the driver waited for each pizza to be baked before taking the next order. And here we switch to non-blocking I/O. where the driver can take multiple orders and deliver them as soon as each pizza is ready. In the non-blocking example, all three orders are placed almost simultaneously. Node.js doesn't wait for each file to be ready before moving on to the next one. Instead, it starts reading all files at once, and when each is ready, it completes the order. This makes the process much faster and more efficient. Why is non-blocking I/O awesome? Because speed and efficiency. Just like our pizza delivery driver, Node.js can handle many requests at once, keeping things moving quickly. And next, resource utilization. Instead of wasting time waiting for one task to finish, Node.js makes the most of its resources by tackling multiple tasks simultaneously. Next, scalability. Non-blocking I/O is one of the reasons Node.js is so good for building scalable network applications like real-time chat apps, APIs, and streaming services. As a conclusion, non-blocking I/O in Node.js is like running an efficient pizza delivery service. By not waiting around and managing multiple orders simultaneously, Node.js can handle a high volume of requests quickly and efficiently. This is what makes Node.js so powerful for modern web applications where speed and scalability are crucial. In this video, we are going to talk about Node.js web server and doing this with HTTP module. Imagine you are an architect tasked with building your very own virtual world, your first web server. Think of it as creating the entrance to your digital kingdom, where every visitor is welcomed with a personalized message. Every great structure starts with a solid foundation. In the world of Node.js, that foundation is the HTTP module. This module is like your toolkit, providing everything you need to construct and manage the flow of traffic into your virtual world. Here you are grabbing the essential HTTP module, the cornerstone of your web server. It is like picking up your hammer and nails, ready to start building. Next, you'll need to set up the main gate. This is where visitors will enter. This is where the magic happens. You'll create a server that listens for visitors knocking at your door. Imagine this code as the welcoming committee at the gate. Every time someone approaches, your server checks it is and then responds with a warm greeting. In this case, it is a simple hello world, a classic way to greet your first visitors. Every kingdom needs a location. For your server, this location is designed by the port and host name. It is like putting your kingdom on the map. Here you are telling your server to be available at 127.0.0.1 on port 3000. It is like saying, my kingdom is open for visitors at this address. Now anyone who knows this address can stop by and receive your warm welcome. But what if you want different parts of your kingdom to do different things. Maybe you want to have a special area for introductions and another for learning more about your world. Now you have created different gates in your kingdom. When someone visits, they they are welcome to the home page. When they go to about, they learn more about your world. And if they wander off to an unknown path, they'll get a friendly page not found message guiding them back on track. Finally, it's time to open the gates. Run your server with Node.js command. And just like that, your virtual kingdom is live. Open your browser and visit http 127.0.0.1 3000 port, and you'll be greeted with your personalized message. Your server is now welcoming visitors, guiding them through different parts of your world based on their requests. Congratulations! You've just built your first Node.js web server using the HTTP module. This is just the beginning of your journey into the vast world of the web development, where your kingdom can grow into something as big and complex as you can imagine. Keep exploring, keep building, and let your creativity guide you. In this video, we are going to learn file operations in Node.js and also directory operations. Imagine you are building a Node.js application and you need to manipulate files. So, the Node.js file system module is like your trusty toolkit, ready to help you handle all these tasks with ease. Let's explore how you can use them. First of all, you implement this method here to unpack the toolkit. You don't need to install anything, you just implement this one, that's it. So how do we read files? Here we have asynchronous communication, asynchronous implementation, this one. As you see here, there is lambda method here. This represents asynchronous architecture. So we have read file. This is the file name. This is the format. Okay, next one is synchronous. As you see, synchronous communication is like this. We only need to call the read file synchronous method here. We read the file. So next one is writing files, writing something to files. Alright, this one is asynchronous communication. We call the write file method here. We write this message into the text file. The name of the file is message.txt. And synchronous communication. So we call this method write file synchronously, and we write this string to the file. And here appending files. This one is asynchronous. We append this one to the file. Our file name is message.txt. This one is asynchronous. This represents here it's asynchronous. And synchronous implementation. we call this method only here, and we add this one to the message.txt file. And next, how do we delete files? So we call unlink asynchronously, and we delete this file. So this one message, and synchronous here. Alright, this one we call this method here. And here, how do we create directory? mkdir method, we call this one. It's similar to the command line prompt command. So we call this as an asynchronously, and we create directory with the name of this, and we use synchronously. We call this method here, and we create this folder. And this represents how do we read directories. So again, this one is asynchronous communication. We read the directory here, all the files we read, and so you can access the files from this variable. When you read the directory, all the files comes to this variable. And this one is synchronous communication. We call this method for reading the directory. And how do we handle errors? So as we have seen before, in the asynchronous communication, we call this block to handle the errors. If there is an error, it prints the error message here. So as a summary, Node.js module is like Swiss Army knife for file operations. Whether you are reading files, writing logs, creating directories, or managing files, FS has got you covered. With this toolkit in hand, you can confidently build, explore, and manage the file system in your Node.js applications, creating new worlds, or just keeping your logs in order. In this video, we are gonna talk about Node.js callbacks. At the heart of Node.js lies a powerful concept that allows it to handle multiple tasks at once. These are callbacks. If you have ever wondered how Node.js manages to stay responsive while performing time consuming operations like reading files or querying databases, the answer lies in its non-blocking, asynchronous nature powered by callbacks. A callback is simply a function that is passed as an argument to another function, which is then executed after the completion of a task. This approach allows Node.js to continue processing other code while waiting for the callback to execute, making your application faster and more efficient. So, let's see a basic example how a callback works. In this example, fetch data here simulates a delay with set timeout. Once the data is fetched, the process data callback here is executed, Even though the data fetching takes time, Node.js doesn't get stuck waiting. It moves on and processes the data when it's ready. As you see here, fetch data gets the callback parameter. So this one is function. Fetch data gets the function parameter. And here we call the fetch data here. Again, fetch data gets process data gets this function as a parameter, and this one is callback. So Node.js callbacks are commonly used in file system operations. Here's an example of reading a file asynchronously. In this case, fsRead file reads the file, and once it is done, it invokes here the callback function. If an error occurs, it passes the callback as the first argument, allowing you to handle it gracefully. As you have seen, this one is asynchronous implementation. It automatically uses the callback mechanism, callback function in its inside. Node.js follows the error first callback pattern, where the first argument of the callback function is reserved for error handling here. As you see, this standard ensures that you always check for errors before proceeding with your logic. As your code grows, you might find yourself nesting callbacks within callbacks, leading to what's known as callback hell. It's a pyramid of doom that's hard to read and maintain. Here are a few strategies to avoid it. Modularize your code. Break down your logic into smaller functions. Use promises or async await, modern alternatives to callback that can help streamline your code. Control flow libraries. These are the tools like async.js can help manage complex callback chains. While callbacks are foundational in Node.js, promises and async await provide a more readable and manageable way to handle asynchronous operations. Promises help avoid callback hell by allowing you to chain operations, and async await further simplifies asynchronous code. As a summary, Node.js callbacks are the building blocks of asynchronous programming, enabling your application to handle multiple tasks simultaneously without getting bogged down. By mastering callbacks, you unlock the full potential of Node.js, ensuring your code is efficient, responsive, and ready to handle the demands of modern web development. In this video, we are gonna talk about Node.js event loop. The event loop is the core mechanism in Node.js that handles asynchronous operations, allowing Node.js to perform non-blocking I/O operations despite being single-threaded. It manages and processes multiple tasks concurrently, enabling high-performance applications. How does it work? One is phases. The event loop runs through different phases in a loop, each handling specific types of tasks such as timers, IO callbacks, and more. Next, task queues. Tasks are placed in queues like the callback queue, microtasks queue, and others. The event loop picks tasks from these queues and processes them. Next, timers. Functions scheduled with set timeout and set interval are executed during the timer phase of the event loop. There are some phases of the event loop. One is timers. It executes callbacks from set timeout and set interval. Next, pending callbacks. It handles IO callbacks that are deferred to the next iteration. Next, idle prepare. These are internal use only. Poll retrieves new IO events and executes related callbacks. Next, check executes callbacks from set immediate and close callbacks. This handles closed events like socket.onClose. There are some key points to remember. One is non-blocking I/O. This is the event loop allows Node.js to perform I/O operations without blocking the main thread. Next, single-threaded. Despite handling many tasks concurrently, Node.js uses a single thread, with the event loop managing the distribution of these tasks. Next, microtasks. Promises and other microtasks are handled after the current operation completes and before the event loop continues to the next phase. There is an example here. So the synchronous code runs first here, this one runs and this one runs, then microtask queue is processed. So in the microtask queue, promises are handled here. Promises are handled. This is processed after the synchronous operations. So after that, event loop continues to the next phase. So set timeout callbacks are executed here. So why it matters? Understanding the event loop is crucial for writing efficient non-blocking code in Node.js. It helps in optimizing performance, avoiding pitfalls like callback hell, and managing asynchronous tasks effectively. As a summary, the event loop is a fundamental feature of Node.js that manages asynchronous operations and allows non-blocking I/O despite Node.js being single-threaded. It processes tasks in a loop through various phases, including timers, I/O callbacks, and more, ensuring efficient handling of multiple concurrent operations. Let's remember the keys here. Phases. The event loop runs through different phases, handling tasks like timers and I/O operations. Non-blocking I/O allows Node.js to perform I/O operations without blocking the main thread. Microtasks. These are the promises and microtasks are processed before moving to the next phase. In this video we are gonna talk about Node.js path module. Picture this, you are deep in the code, moving files around, building directories and juggling file paths like a pro. But then the paths start getting messy. Slashes everywhere, relative paths leading who knows where. Enter the Node.js path module, your ultimate navigation tool for taming the chaos of the file and directory paths. No need for fancy installs, just require the path module and you are ready to start exploring. Ever had to piece together a file path from different parts? Instead of manually figuring out where the slashes go, let the path module do the work. When you need the full absolute path to a file, no matter where you start, path.resolve has got your back. The path module isn't just about creating paths, it's also a master at analyzing them. As you see, here is find the directory name, and here you get the base name, and here extract the file extension here with these methods. Paths can get messy with unnecessary slashes and relative segments, but path.normalize comes to the rescue, tidying everything up. Break a path into its components with path.parse or put it back together with path.format. It's like playing with building blocks. So here path parse is used like this, and output is here. It gets almost everything about the file, and construct a path here. You enter these ones and you get this result. Whether you are on Windows or a POSIX system, the path module keeps your paths consistent. Need to find the quickest route from one directory to another? Let path.relative guide you. As a summary, Node.js path module isn't just a tool, it's your GPS for navigating the intricate landscape of file and directory paths. With its powerful methods, you can create, dissect, and normalize paths effortlessly, making sure your code runs smoothly across different environments. Whether you are building routes, organizing files, or cleaning up paths, the path module ensures you never lose your way. In this video, we are gonna talk about understanding Node.js promises. Promises in Node.js are a way to handle asynchronous operations. They provide a cleaner and more manageable way to deal with the tasks that take time to complete, such as reading files, making HTTP requests, or querying databases. A promise is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. These are the some basics of promises in Node.js. First one is pending. This is the initial state when the operation has started but is not yet finished. Next one is fulfilled. This is the operation completed successfully and the promise has a value. And next one is rejected. This is the operation failed and the promise has a reason for the failure. When you create a promise, you pass it to a function with two arguments here, resolve and reject. Inside this function you perform asynchronous operation. Here is asynchronous operation since the lambda method here. If it succeeds you call resolve value, and if it fails you call reject value. So these two returns successful or failed. One of the powerful features of promises is chaining. You can chain multiple then calls to perform a series of asynchronous operations in sequence. Each then method returns a new promise, allowing further chaining. As you see here, there are two then method here, and both of them returns different result. Here you see promise all usage here. How to implement promise all? So it waits for all promises to resolve. If any promise is rejected, it returns the rejection. And promise race here. Promise race returns the result of the first promise that settles either fulfilled or rejected. And here, using promises with async await. While promises are great on their own, they shine even more with async await, which allows you to write asynchronous code that looks synchronous. So we can use promises with async await architecture. Here, as you see, async keyword here defined, and we have await keyword here, and it makes more efficient code when we add async await to the promises. As a summary, promises in Node.js provide a clean and efficient way to handle asynchronous operations. A promise represents the eventual completion or failure of an async task and allows you to manage results or errors without falling into callback hell. And some key points here states it's a promise can be in one of three states: pending, fulfilled, or rejected. And usage of promise: use then method to handle successful outcomes and catch for errors. And chaining: promises can be chained to execute async tasks in sequence. And promise all, promise race: combine multiple promises to either wait for all the resolve or return the result of the first settled one. And async await architecture simplifies working with promises, making async code look synchronous. In this video we are gonna talk about Node.js async await. Async await is a syntactic sugar built on top of promises in Node.js. It allows you to write asynchronous code that looks and behaves like synchronous code, making it easier to read, write, and debug. Async keyword declares an asynchronous function. This function automatically returns a promise. Await keyword pauses the execution of an async function until the promise is resolved or rejected. The result of the promise is returned or an error is thrown. Here is the example how you can use async and await to handle asynchronous code. As you see here, we use async keyword and we have await keyword here. So we call fetch method here, we call the web API, and we return the JSON format here. So these are not blocking each other, since these are asynchronous function. There are some key benefits of using asynchronous. So first, readability. Code flows naturally without the need for chaining then methods. Error handling. Use try-catch blocks to handle errors, making it consistent with synchronous code. And debugging. Easier to debug than promise chains, as stack traces are simpler to follow. You can handle multiple promises in parallel using await with promise all. As you see here, we use promise all, and we handle multiple promises here. We use fetch then, and next one is here. When do we use async await? So when we have multiple asynchronous operations that depend on each other, we use async await. When we want cleaner, more readable code compared to using promise chains, we use async await. When we need to handle errors in a more straightforward manner, we use async await. As a summary, async await is a way to write asynchronous code in Node.js that looks and behaves like synchronous code. It builds on top of promises, allowing you to pause the execution of an async function until a promise resolves or rejects. The async keyword declares a function as asynchronous, and await pauses its execution until the promise is fulfilled.